So here we are at chapter 13. You've either just finished going through the first 12 chapters with all the introductions to Objective-C and all the constructs from a fairly beginner level, or you've just jumped straight here and joined us because you're an experienced programmer and you're looking for just a real crash course in the raw syntax before we get on to the very Objective-C parts of Objective-C. So what we're going to do in this section is we are going to basically fly through again with just raw facts, basically, all the stuff we've covered in the last 12 sections, so that hopefully if you're an experienced programmer, you'll just pick up all the syntax for if statements, etc., etc. And for the rest of you who have joined us from the beginning, this is a good review time for you, and hopefully you'll understand everything we do in this section. And if you don't, it's a good opportunity there to go back to the individual section on each of those things and take another look. So, are you ready to go, Jiva?
I think I am.
Then crash.
All right, well, crash. So the important things to remember are, first of all, of course, Objective-C is built on top of C. So if you already know C, it's pretty straightforward. Some important distinctions, though, is that Objective-C files are named .m with a .m extension. Their implementation files are. And then the header files are still named with a .h extension. So when you're working with Objective-C code, and when you're writing Objective-C code, you want to make sure that you use those extensions so the compiler will compile it as Objective-C versus C or C++ or whatever. Some other things to remember, of course, I put together this sort of mocked up kind of program here so that we could kind of go through all of the things that we've kind of talked about here. Just like in C, if you want to declare a variable, you have to declare your variables in order to actually use them. So when you go to declare a variable, you want to make sure that you specify its type. For example, in this case, it's an integer, and then its name. And then you can either choose to initialize it by setting its value with equals, and then whatever value you want to assign to that particular variable. All statements in Objective-C must be terminated with a semicolon unless they're compound statements. Compound statements being things like if statements and for loops and even functions and things like that. Those are compound statements. Those don't need semicolons. So you can create variables by declaring them. Here we're declaring another variable called y, and you can assign values to those variables using the equals operator. If you want to create a function that takes a parameter, you can just create the function. In this particular case, this one is called do something with y, and the idea is just that you've got this y variable here, and we've created this function up here where we pass in a parameter of y. Again, just like when you're declaring the variables inside of your program itself, you have to declare the variable parameters that your function takes. So in this case, we're specifying that this takes an integer, and we're calling that integer y here. And when you want to return something from a function, you use the return statement, and then you specify whatever you want to return after that. Again, got to have a semicolon on the end of that. You specify the type of value that functions return by specifying the type in front of the function name when you're declaring your function. Now, if you want to have your functions in another file, like I said, you have these .m files that'll be compiled and so forth, then you need to declare them with the extern keyword. So you have to declare them in the header file or the interface file. So you say extern, and then you do the same thing with the function signature in your header file as you'll use when you actually specify the implementation or when you define the function. So this is the declaring part of if you have a function in another module. In this case, because it's a single statement, it's not a compound statement because you don't have the function body. Of course, it's got to have a semicolon on the end of that as well. Then in the .m file, you can specify the definition of your function. So in this particular case, for example, we're specifying this is the function body for that manipulate x function that we had defined or declared in the header file that we just looked at. Now, this particular function, this manipulate x function, rather than just taking a regular parameter, which would normally be passed by copying it to the function. This one's actually taking a pointer to an integer, and so we're getting the address of that variable and passing the address to that manipulate x function. So if you look here, that's what we're doing here with that address of operator. So rather than actually passing a copy of x, we're actually passing a pointer to x. So inside of this function, then, we can actually use the dereference operator to actually change the value of x in the calling function if we want to. Normally, it would be passed by copy, and making changes to those variables would not change the variable in the original code.
So we're using the same symbol there in our variable, function declaration there. We have it's indicated that it's a pointer to an integer by the fact that the variable name is preceded with an asterisk.
Correct. That's the pointer operator.
It's the pointer operator, and then the dereferencing is done in the same way.
Right.
Okay, so they're both things there. Now, if you don't come from a language that uses pointers or have an understanding of pointers, we're not going to go through it again here. You really do need to go back and find the pointer section in the previous stuff and go through an understanding of pointers. Not a huge problem to us in Objective-C, but the understanding from that will be very useful to you later on. So even if every other construct about languages is fine for you, but you've not come from a language of pointers, go back and have a look.
Yeah. And that brings up also the point that that of course you've got this dereference operator, which is an operator, and Objective-C has a whole bunch of different operators. We went through and looked at all of the different operators when we were reviewing that, and the order of operation for each one of those operators. So, remember we've got addition operators, we've got increment operators, decrement operators, we've got multiplication and subtraction, bitwise shifting operators, and things like that. And those all have a specific order of operation that they will be executed in, just like with math. And you can use those in like if conditionals, and you can use them for manipulating various variables by using the assignment operators and things like that. So returning to our code then, so we've got so that's the manipulate x function with the pointer operation there. We also talked about structures. Structures are almost like sort of a lightweight object, in that you can sort of encapsulate groups of variables inside of a structure, and you can use that structure as sort of a package of things. And so to define a structure, you can use the struct keyword and then specify the variables that are included in that. For example, here we're creating a structure called myPoint, and then we're specifying that structure has two member variables, int x and int y. And so those two member variables will be available anywhere that we create one of these myPoint structures. So we can access this, and we can say myPoint.x, and we can access that variable off of that. We also talked about how you can use the typedef keyword to actually create your own type as part of the Objective-C language. So in this case, we're actually saying, I want to create this type called myPoint, and it's actually this structure. So wherever we see myPoint used as a type, it'll actually substitute this structure here. And in fact, actually down here, we go ahead and we create a myPoint point. And
it was worth pointing out that the typedef there is optional.
It is.
Because if we didn't use it, but we would have to then use the struct keyword with the myPoint declaration.
Exactly. If we didn't have that typedef there, then we'd actually have to do something like struct right there. Now, of course, to pass multiple parameters to a function, you separate the arguments by a comma. If you don't want to pass any parameters to a function, you can just put the two parentheses and have nothing there. Same thing goes with when you're declaring a function that takes no parameters. You just put the two parentheses. So, for example, if you had foo like that, that would be a function that takes no parameters at all. If you wanted to specify a function that returns nothing, then you use the void type as the type that it returns, which basically means nothing. It just goes off into the black hole, the void, right? Now, in this particular case, so the make a point function here is taking two parameters, x and y, and it's going to make one of these point structures for us. So we talked about how you could create a point variable, right? Just like I said with using the myPoint type. So you say myPoint and then the variable name. And then if you want to, you can also use this special structure initialization syntax that allows you to pass the values to be stored in both of the variables that are part of that structure just by passing them inside of curly braces and separating them by commas there. So that'll actually initialize each of those variables with the values that we've passed there. Of course, you don't have to do it that way. You could also do, for example, you could say ret.x equals x, which would specify, which would allow you to assign the passed in x variable to the x member variable of the ret variable, which is of type myPoint. So that's basically working with structures. Then we talked about conditionals and program flow. So, for example, there are three different conditional program flow statements. There's the if, the switch, and the ternary. And the if statement gives you the ability to sort of have a fork in the road in your code, right? So you could say, for example, if, well, in this case, point.x is greater than 10, or, using the or operator there, point.y is equal to 50, then we would execute the code directly after that. If that evaluates to false, then you have the optional else keyword that allows you to specify another code block that could be executed in the event that the if statement evaluates to false.
I think it's probably worth pointing out as well here, isn't it, that the curly braces are used to define blocks of code, but
Correct.
equally, any variable or anything declared within that block, its scope is that block.
Exactly. We did talk about scoping and how the scope of a variable depends on where it's declared. So a variable declared within curly braces has scope only within those curly braces. If you declare a variable inside of like this if statement, for example, and then you try to use that variable outside of those curly braces, then you're going to have a problem. If you declare a variable outside of any curly braces, just out in the file itself, like for example, if we did it up here, then that would actually be a global variable. And we talked about the fact that global variables aren't all that great of a thing to use or abuse, I should say. But it's another tool in the toolbox if you actually need it. Now going back to if statements again, of course, there's also, in addition to else, there was also the else if statement that we talked about. So that gives you the ability, again, if that initial if statement evaluates to false, then you can also say, well, okay, if that one didn't evaluate to true, then if this additional statement evaluates to true, something here, right? Then execute this block of code right here versus strictly going down to the else. And if this does in fact evaluate to true and actually executes, then the else statement will still be not executed, just like if the initial if statement evaluated to true and it executed.
Okay.
So that's if statements in a nutshell. We also talked about switch statements, which are used for the purposes of simple switches on integer values. So in this case, you have switch and you have to pass in an integer value as the conditional variable. You can't use anything complicated here like, strings or something like that, right? You can only really use integers here. So what it does is it actually says switch integer value, and then if that integer value, that variable, is equal to, say, for example, 10, then it will go through each one of these cases, it'll evaluate it against each one of these cases, and whichever one it is equal to, it'll execute all of the statements inside of that case block. Another important aspect of that, of course, is that it'll execute each one of the statements after the case that matches until it either reaches a break statement or until it reaches the end of the switch statement code block. If you leave off the break, for example, here in case 30, right, if we leave off that break, then what will actually happen is it will execute not only the stuff that's part of the case 30 block of code, it'll also come down here and execute this additional default action as well.
It continues to drop through the code until it finds a break or the end of the scope, the end of the compound statement.
Now, if it doesn't match any of these cases, so if in this case, point X was not equal to either 10 or 20 or 30, then it will always execute the default code block instead. So that's a switch statement in a nutshell.
Okay.
We also talked about the ternary operator, which is not used so often, but is still an important thing to know about. And that's actually down here, where we're doing the ternary operator is basically, it gives you the ability to sort of do a short, terse if statement and return a value based off of whether or not the if statement evaluates to true or false. And so the way that works is you essentially specify the conditional parameters here. So the first thing you do is, like, for example, in this case, we're saying if point.x is greater than point.y, and then you specify the ternary operator, which is the question mark operator that tells the compiler that we're doing a ternary operation. So if that evaluates to true, then the next thing after the question mark operator is what will be returned and from that ternary operator.
So if x is greater than y, 100 will get returned.
Correct. Otherwise, that's what this colon specifies. That's sort of like a little mini else. It'll return 200.
Right, okay.
So if point.x is less than point.y, then we'll return 200 there. And of course, in this particular case, we're just storing that into our z over here, just for the sake of showing that. So the other thing that we talked about is loops, right? Which was, we talked about using the indexed loops where you can say for integer n is equal to 0, n is less than some value, increment n, and then you can execute this code over and over again until the conditional statement evaluates to false. In other words, it'll keep executing this until that statement is no longer true. And it does that essentially. The for loop consists of, inside of this conditional statement here, you have the initialization portion of the statement here.
Just gets run when it arrives there.
Right, that gets run the first time you create this control variable n. Then the conditional evaluation, this is the thing that's checked each time to see if we should keep going.
So it keeps going, well, that is true.
Correct. And then finally, whatever you want it to do to change that variable. So in this particular case, we're just incrementing that variable on each loop through the loop. And of course, this could be plus equals 2 if you wanted to like skip every other element or something along those lines as well. So as long as that's executing, right, it'll go ahead and iterate over each of those elements, and you can do something. That integer n there is available, it's within scope within that for loop. So you can use that n value to access the elements of an array or to do calculations or whatever you want. Now, we also talked about fast enumeration. I didn't put anything in here on that because we're really going to talk about that more when we hit on the collection classes. So I don't think we really need to review that too much. But
okay, so just before we move on to the other type of enumeration, a couple of things. I think it's worth pointing out that we can break out of a for loop with a break statement.
Yes.
We can skip to the next iteration with a continue statement.
Yes.
But the thing I'd like us just to pick up on is that NS integer thing.
Yes.
Because that's not maybe what we would call a standard type. I'm doing this again.
That's true.
I managed to avoid that for several chapters and we're back. With a standard type. So just quickly remind us what NS integer is.
Well, if you're already a C programmer and you're familiar with kind of the mess that occurs with certain integer types depending on your architecture. The NS integer value is really provided by Apple to help mitigate that problem a little bit. You know, we know that, for example, array indexes, when you are working on a 64-bit platform, it's possible to have array indexes that are very, very large, things that wouldn't normally fit into just an integer or just a long or something like that, right? And so really the NS integer is provided and specified to be the largest pointer size that the platform supports. So if it's a 64-bit platform, then it will give you the ability to address all 64 bits of address space. If it's a 32-bit platform, then it will give you only the ability to specify or to access that 32 bits of address space.
So we have NS integer and NSU integer for the unsigned version.
Correct.
Okay. Okay. Sorry.
No, that's a great point, and
reservations.
it's a sort of a platform specific thing, because it's something that Apple provides, and it's got that NS on the front of it, so that shows you that it's one of those Apple provided data types. So moving on, we also talked about the while loop, where we're basically this is useful when you have a variable that's already been specified and you want to do a certain action as long as it's within some parameters. In this particular case, we're saying while point.x is less than 20. The convenient part about that is that, of course, like I said, it's useful for when you want to work with variables that are already specified or where those variables might need to be changed outside of your loop. But an important distinction, of course, is to remember that the while loop, the conditional for the while loop, will be evaluated the first time you come in here. And if that variable does not make that conditional true, then it's possible that your while loop may never actually run. It just might skip over it. So again, the way that works, of course, is, it says while whatever the conditional statement is true, do this stuff. So that's the while loop. Finally, we have the do while loop, which is sort of a while loop turned upside down, in that this executes its code at least once and then evaluates the conditional statement at the end of executing that loop. If it evaluates to true, then it goes back and it runs again. And it'll keep doing that until it evaluates to false, and then finally it'll stop. The nice thing about that is that you're guaranteed that code's going to execute at least once. So for example, that can be useful if you need to, say, initialize whatever variable it is that you want to use inside as your conditional variable. If you need to do some kind of calculation and set a value on that at least once, then this is a convenient loop to use for that particular case.
Okay, that's been great. I think there's just maybe a couple more things we just need to basically review as well. We use some preprocessor directives to make sure that our code in one file understood about code in another file. And so maybe if we just quickly review those.
Right. So when we started this discussion, I mentioned that the compiler knows what type of code you're compiling based on the extension of your file, the .m file or the .c file if you're compiling C code. And that I took a couple of functions and I moved them off into this other unit, this compilation unit called my other functions. And I created just a couple of functions in there. And so the question is, so I've got these functions specified here. How do I pull these interface definitions into my main module?
So we split it up. We created one file, the .m file,
right,
or the .c file if we were just doing raw C, I guess, that contained the code we wanted to run, and then a .h file which just contained
the
declarations.
Declarations, right.
Okay.
And so what you need to do is you need to pull in those interface declarations, and then so that they're available in this code, so that the compiler knows, hey, here's some functions that I'm going to be using. And to do that, you use the import directive. Now this is different from C, especially if you're coming from C, if you're coming from C++, you're probably familiar with the #include directive, which #import is very similar to that, But again, if you're working with C, if you're working with C++, you're probably also familiar with having to write header guards around your headers all the time. And the pound import directive makes it so that you don't have to do that. It automatically checks to see if your header file has already been included, and if it has, it doesn't re-include it a second time. So you don't have to do that kind of stuff. Now, when you're specifying the files that you're importing here, you can either use quotes or you can use angle brackets, as we're doing here. So here's angle brackets to specify that we're going and getting this foundation header. You use the angle brackets when you're trying to access header files that are provided by the operating system or by the SDK. That causes the compiler to go out and search the SDK header include directories rather than your own project's include directories. When you specify the header name using quotes, you're actually saying this header file is actually part of my project. So look in my project include directories first. Does that make sense?
Yep, makes loads of sense.
Awesome.
So that has been a rapid review. So if you've been watching with us for the last 11, 12, 13 chapters, and all of that should have made sense. If it didn't, you probably need to go back to the chapter that you just got lost on our review there and watch it again to get the foundation. If you've joined us straight away on this chapter because you're a competent programmer in another language, you understand a lot about language constructs, hopefully most of that would have made perfect sense. You're just after the syntax for the while loop and the for loop. If any of that didn't, then just go back to the individual chapter that covered it and check it out. But realistically, we've been basically dealing with C,
right,
making one or two sort of nodding acceptances that we're dealing with Objective-C, like the import instead of the include statement, NS integer,
right,
and certain things like that. But now we have this C language foundation. We're going to move on to the real Objective-C stuff.
Right, yeah. Objective-C, of course, is based on C. And so if you're really completely new to the platform, if you're completely new to the language, this material that we've covered so far is very much foundational. You need to know this stuff. You need to understand, you've got .m files and you've got, statements and compound statements and stuff like that, for loops. All of this stuff is things that we're going to use when we're working with Objective-C. But the next material that we're going to cover is really the objective part of Objective-C. And this is where Objective-C really starts to get cool. And this is where it starts to get fun.
So, go do any reviewing you've got to do. Go back and watch anything you've got to watch. I suggest you get really familiar with this material before you move on. And when you're ready, come back, join us in the next chapter. We'll wait for you, take as long as you like, and we'll move on.
Bye.